This is a microwave oven electric motor. It is the motor that moves the turntable plate. These are AC motors that work on 110 or 220 volts, depending on your country. These are low-speed motors. They turn at a few RPM because they have internal gears to reduce the speed. This one, for example, turns at 6 RPM, and this other one at 3 RPM. These motors are interesting because they are synchronous motors, which means that they also work as electric generators. If we rotate the axis, an alternating current will be produced at the motor's terminals. I made a hole in the motor's axis so that I can use a crank to make it turn. I have the motor connected to the multimeter, and let's see what voltage do we get. Something around 200 volts. Here I have 30 LEDs connected in series. Let's see if we can turn them on. Let me now try with this 100 watts LED. And there you have it. Of course, the LED does not turn on at full power because it requires 100 watts and these motors can only provide around 5 watts. Since the motor produces AC, we can use a voltage multiplier in order to increase the voltage output. This multiplier has 10 stages. Each stage doubles the input voltage. Therefore, we will have a multiplication factor of 20. Since our motor produces around 2000 volts, that means that at the output of the multiplier, we will have around 4000 volts. I have the motor connected to the input of the multiplier, and let's see if we can get a spark at the output of the multiplier. If we want to use these motors as electrical generators, we have to take into account two things. First, we must find a way to couple the axis to an external source of mechanical energy. Here, we turn it manually. Second, they are low power units, and we can get a power of around 5 watts only.